First, I'm going to be showing how the vertical line test is very helpful in finding whether or not a relation is a function or not. So a function represents one input for each output. You can see that in a circle, it does not pass the vertical line test no matter where we do it. But even if there is only one point that has 2 points in the vertical line test, then it is not a function. So to do function notations, we have our notation at the top and we are going to be plugging it into our question. So we want to look at that and see what we can add in. So in our question we have 2 f of x's and we can see that that equals 3x squared plus 2. So we are going to be doing that for each half of our question. We have this written out, we solve it just like any other algebraic question using BEDMAS. In doing this, we are able to add and subtract when necessary, and we found our independent variable, which is 27. For this next question, we are just going to plug in the notation once again, and when we do that, we can see that it is in perfect square formation, and we are able to FOIL it. So here I am just foiling it to make the process easier. And now that it is foiled, we know it's a squared minus 10a plus 25, and we can just plug that into the brackets. And that gets rid of the squared. And from here, we just continue to solve it by multiplying the 3 into the brackets, and then we collect like terms. Moving on to domain and range, here we have a graph, and the circle means that there's a hole in the graph. And right off the bat, we can see that the domain is XER, which means that x is a real number. But we are able to break it down a bit more using those numbers, and we can say that the furthest x point is -4, so -4 is greater than x. But we also know that it has to be less than 3 or equal to. The reason this one is equal to is because there's no hole in the graph at the furthest x point on the right. For the range, we are going to be looking at the graph and seeing the highest and the lowest point, but we cannot say that y is an element of a set of real numbers because it is 2 separate lines. So we are just going to place out our highest and lowest on the y-axis. We see that this next graph is just one continuous line from point A to point B, so we can say that x is an element of a set of real numbers, and we can break it down more to say that it is greater than or equal to -3 on the x-axis, and we are also saying that it is less than 5 or equal to. There should be an equal to sign under the greater than symbol. And once again, the reason it's equal to as well is because there's no holes in the graph. Now, when finding the range, look at the highest point and the lowest point. So now we're saying that y is an element of real numbers, and then we can dig deeper and just narrow down the numbers more. For our formula, we have it up at the top, which will help us use it as a guide. So here we can see that the 3 value is the letter K, and the other 3 inside the brackets is a D. The K value determines horizontal stretches, reflections, or compressions, and the D determines the horizontal translations. So now we know that it translates 3 units left, and it is compressed horizontally by a factor of 3. So now for my first step of this question, I am finding the values. So there's an A, an X, and a D. And in this case, the A and the D are the most important that we are looking at. We can say that it is compressed vertically by a factor of the absolute of A, and it is 1 unit right. The reason we say right is because there's 2 negatives, which equal positive. So an easy way to find the translations is to inverse f of x. So here I have some points plotted out on a graph, and I'm just going to write down the different points. And then an easy way to do this is you just flip the numbers and rewrite them. So basically just on the opposite side. And those are your new points. Now I graphed out the new points and we see the translation there. It's a reflection, it's not compressed nor stretched either. Now to write out an inverse question. So this is when x is greater than 2. So the very first step is to switch the x and the y values, and then we are going to try to isolate the y. So now we are dividing the 6 down to once again try and isolate the x, and then we are now doing the square root. The reason we are square rooting both sides is to get rid of the squared on the right side. So finally we're bringing the 2 over, and we are writing plus or minus the square root, even though we know that it is just going to be plus because this function is for when x is greater or equal to 2. So now we are just writing it with the inverse symbol in front. And because we know x has to be greater or equal to 2, we know to write the positive symbol when we're square rooting it. And so now we are able to make our little dotted line just to give us an idea of where the graph is going to be. And because it's positive, it is on the right side. Now I'm going to be solving reciprocal functions. So something important to remember when we are doing this is that the first number goes on the bottom and the second number goes on the top, and it equals x. And from there, we are able to reduce it down because this is still over 1. And then we can cross out our common variables, and then it turns into a -1, which we are multiplying in. So we get -7 plus 7, which equals 0, which lets us know that it will be an asymptote. Now for this question, we want to see how we can equal the bottom to 0, and we get -5/6. So the first point I'm going to plot is the -5, 0. A vertical asymptote is when the equation is undefined, meaning it equals 0. So that's why we found how the equation would equal 0. And by using a chart, we were able to find that our next point is not the one that I did right there, but it is actually -3, -2. And then we'll draw the x-intercept line. Our point in between these 2 points is 1, 1. If we plug in the equation going from 0, 1, 2, 3, the 1 is 1, 1, and we can plug that in just a second after we draw this one. And now we just plotted it out, and we are able to see this function.